Welcome again, ladies and gentlemen, to NAPIT EXPO 2014. Carrying on from this morning on the training taster sessions, little snippets of courses that we do run at our training centres around the country. My name is Paul Markham. I am one of the tutors, assessors, lecturers, you name it, come what may I be, at Mansfield. Anyway, good afternoon. This little snippet is from the introduction to the Code of Practice for Electric Vehicle Charging. It's obviously a new technology. We have all these fantastic new technologies, I'll put my teeth in, that are facing us as electrically biased people. There are incentives for people to have these electric vehicle charging points installed. There's grants that can be got for people to put them in, and it is an up-and-coming technology, and like all up-and-coming technologies, it's still progressing and still growing. Can I also mention that we have got a training rig here that we use when we're doing our practical assessments. And you can also, if you would like to visit the Rolex stand that you'll find in the main exhibition hall downstairs. They've got a lot of, to be quite honest, more up-to-date equipment. When we purchased this, it was a few months back, and by now it's evolved quite a great deal. New technology, yes. We at NAPIT run a City and Guilds course. It is a City and Guilds course. It's an approved City and Guilds course. We've had visits by City and Guilds external verifiers. They come round, they check the rigs, they check the environment, they check that we know what we're talking about, and they make sure that we can run the course for them. It is a 2-day course. It covers the Code of Practice, which we'll be talking about in a minute. We have certain practical exercises to do on the rigs that you can see by the side of me, and there are also assessments, paperwork exercises that we must complete. There's a practical inspection of the testing rig as well, filling out of the required forms, risk assessments, DNO forms, electrical installation certificates, you name it, we've got to fill it in. The 2-day course, on the second day you take a online exam. If anybody's taken City and Guilds online exams, sat in front of a computer, multiple choice, this multiple choice exam is 40 questions long, and you get an hour to complete it. So that is the course we offer. A lot of councils, if you are fitting these, they expect you to have the City and Guilds 2919. You will also find that big independent supermarkets such as Sainsbury's, Morrison's, they are turning a lot of petrol stations, and they are making sure that their new petrol stations have got electric vehicle charging points in them. Motorway service stations are following suit. So it's coming, whether we like it or not. The only thing that really worries people about electric vehicle charging is range and distance of the vehicles themselves. The battery technology at this present moment is still limited a little bit. It's, again, evolving every day, and hopefully one day cars will be able to run a good distance. But you do need to have a set change of mind if you're going to run an electric vehicle. It's no good just nipping into a motorway service station just to go to the toilet and a 5-minute cup of tea. You may have to stay for at least 20 minutes to charge your car up in future. So it's a totally different mindset. The whole exam and the whole course is based on the Code of Practice for Electric Vehicle Charging. That is its ISBN number, its International System Book number. You'll find a copy we've got at the front there. It is a book that is produced by the IET. I would, in my opinion, I would refrain from buying it at this present moment in time. Like all publications by the IET, they bring out a version of the regulations, all of the on-site guides, all of the guidance notes and all of the approved documents then have to catch it up. And by the time they've got to the last code of practice and it's caught up, unfortunately the regs changes again. So we're always in a state of flux catching up. This is a little bit out of date, but it is what City and Guilds use for their question material. It is also based on the new Section 722 of BS 7671. Amendment 2 was just for electric vehicle charging. It was never brought out as an addition to the book. It would probably be a waste of money to do that. So what they did is put it on the IET website, and if you go on the website that is shown on the screen, you can actually get and download free of charge the Section 722 for electric vehicle charging. The book applies to the installation of dedicated conductive charging systems for pure electric and for hybrid electric road vehicles. It talks about AC and DC charging equipment for the domestic market, on street, commercial and industrial installations. It does not apply though to local planning regulations and building regs. If you are putting this in on street, you would obviously need to consult councils and work with the Traffic Act, Highway Traffic Act and all sorts of things. So it mentions it in the book, but it doesn't apply to it. Like all examinations, and City and Guilds examinations, and those that have taken them will know, there's always the statutory regs bit where you need to be able to relate to actual documents that are the law. Codes of practice and even BS 7671 is not the law. They are written to help you comply with the law. Those are the law. In front of you, Health and Safety at Work Act, everybody's aware of, Electricity at Work regs, the ESQCR regs, they're the supply regs, the overhead lines, transformers, etc. The traffic management order, as I've mentioned, is definite if you're going to do on-street electric vehicle charging, along with planning consents. Building regs come into it, especially Part P. This is a brand new circuit, and a brand new circuit needs notifying to building control. So it's a notifiable job. In the book, it talks about different modes of charging. There are 4 modes. Mode 1 is a normal plug-in 13 amp socket. This country is the only country that has this mode, and it will be one day outlawed in this country very soon. The problem is BS 1363 sockets are not made to take a constant current load. They are on-off 5-minute, 10-minute intervals. These things require at least 10 amps, and if you're drawing 10 amps continuously, I'm afraid you get the results that you get on the pictures. The sockets are not designed specifically for large currents for long periods of time. Coiled up extension leads results in the right hand side, and it is a problem. There's a problem that you could be plugging your car onto a circuit that was wired prior to the need for RCDs. So at the end of the day, mode 1 will disappear and should really be discouraged. Mode 2 is a standard socket, but they recommend a industrial type socket, 60309/2 commando socket. The socket arrangement, the pin arrangement, the pins are barrels and they fit into a cylinder, and it is total contact rather than a pin fitting into a U-clip. So the contact is better. The earthing pin on the CPC is bigger, and so you have a better CPC connection. The Mode 2 also has, as you can see with the lady present, she has a lead that has a control box in the middle of it, and that control box has in it, as it says on the slide, thermal protection, overload protection, and a Type A RCD. We'll come to that later. It also communicates with the electric vehicle. You'll be able to see from the piece of equipment to my left later on, it's got a little electronic component in it that they call a Mode 3 controller. And a Mode 3 controller, the vehicle and the Mode 3 controller talk to each other, if you like. And they know when they're full up charged. They can switch off if the protective conductor continuity goes down. So it's always keeping a check on the system, whereas a Mode 1 has no checks whatsoever. Mode 3 will be the most common. Mode 3 is what you see over here. And Mode 3 is, and I'm moving away from that mic, for somebody's drive or somebody's on street, and on the other side you can have these, and you can have a look at them later on. You can put people in people's garages, on the outside of the garage, and these are the Mode 3 controllers. Single phase, 16 or 32 amp, you can have them both, but you've got to be careful on that. And again, if you have a look at the plugs and socket arrangements, you'll be able to see that they are not just positive and negative. There's other conductors in there that monitor the vehicle setup, the PC, and make sure that it is getting its right charge. One quick boost and then it slows it down bit by bit. So that is Mode 3. Mode 4, well, Mode 4 will be the petrol station and the motorway service station equipment. This will be DC, not AC. This will be straight DC. It'll be rectified in the equipment. The equipment will look just like a normal petrol pump for all intensive purposes, but instead of a nozzle it'll have a plug and socket, and it's typically 500 volts, 125 amps, DC, quick charge. Something like this can take 16 amp will take 12 hours to 16 hours to charge, 32 amp will take about 8 hours to charge, and this DC equipment will take about 20 minutes. But you are plugging DC straight into the car. That's your Mode 4 stuff. As I say, they're designing it on purpose to look like a petrol pump, because that's what we know. That's what we see, and so we can relate to it. We can just pull up by the side of it. My problem is I can see lots of people trying to get the socket in the petrol cap and all sorts, but it'll happen. We know it's going to happen. But again, it's got all the facilities on it that are built into the smaller units, the overload protection, RCD protection, and the PC continuity check. It's very important, the PC continuity check. That metal car, you're going to connect to an electric supply. If it hasn't got an earth, that is one big surface area for you to get an electric shock off. The AC connections, again, if you have a look at the plugs we've got in front of us, at the minute, internationally, there's a bit of a problem. Because we, in the UK, and most of the European Union, use the Manekis. They're all Japanese produced, Korean produced, but the Manekis which you see at the bottom. Italy and France want the middle one, and Japan and the USA want the top one. So there's a little bit of difference of opinion of which plug and socket arrangements we're going to be using on the car. This is the car. The left-hand side is the car, and as you can see, you've got two in-point points. One is for your AC, which is for your Manekis, and the large one on the right is the DC Chadimos. These are the plug and sockets that you will find on the motorway service stations. Again, you'll notice larger. Plug socket arrangement is larger. You've got larger currents, and you've got lots of voltage, so you've got to be very careful with it. There are also connecting modes. All questions will turn up on connecting modes. You've got your charging modes, you've got your connecting modes, different cases. There's only 3 cases. Case A is where the lead is permanently connected to the vehicle. I only know of one electric vehicle, and it's called the Renault Twizy. Lovely name. And it's a little 1-2-seater smart car for round town job, and it's got its own extension lead in the boot. That is the only one I know that is made with this Case A system. Case B will be the common. It's the extension lead that comes off both ends. Something like this piece of equipment here. Longer obviously, but it will detach from the charging equipment and it will detach from the vehicle. And then if you leave it in the garage and you need it at the petrol station, you better hope somebody else has got one or the petrol station's got one. So I would suggest you always carry it with you. And Case C is the tethered job. The tethered job will be the service station again, the petrol pump. It'll be stuck to the equipment. Actually, the one on the front facing you is tethered as well. That has got the lead permanently connected to it, and the other end obviously just goes straight into the car. Lots of questions in the exam, and it's important, I know, but there's a few things you must get ready for. You must do a site visit. It's got to have a site visit. People to check this and to do this as over the phone, it's not really possible. And if it's not possible to do a site visit, then it needs to be written into something in the quote that there may be extra additional costs on it. We'll come to why later on, but it's not just a case of installing a radial circuit, I'm afraid. A lot of people have rung up and said, you know, what is there to installing a radial? It's just A to B and that's it. It's the periphery bit around it involving the types of earthing systems that we've got and the earthing arrangements. Always need to be on a metered supply. Unmetered, you'd have to get in touch with your DNO anyway. I don't know even why that's in the book, but there you go. Landlords need to give their permission. There is no diversity allowable on this piece of kit. If you've got a 32 amp mode 3 controller, then that is 32 amps that electrical supply will be taking. No diversity. It's just straight on it. And you need to check the earthing arrangement. Usually when we install these, we will be installing these to a TNCS system, a PME system, today's modern earthing system. And the problem is when they go out of the envelope of the building and you're out the equipotential zone, you leave yourself open to unfortunate happenings if we lose the neutral. If the supply authority neutral goes down on a TNCS system, the voltage on the earth will increase. And if it increases on the earth and you touch it, it's going to hurt. So there's a problem with the earthing systems being as they are today. We'll come to that in a second. You also need to make sure that the existing installation is adequate. It's no good having an installation that is 50 amps and you've only got a 60 amp supply in it, and then you're going to put another 32 on it. It won't have it. You've got to make sure that the charging equipment is put in the right place. There may be other switches that you're going to put in place, isolation switches. If it's on the outside of a garage, you don't want next door tapping into it, so you would put an isolator in the garage to make sure nobody else can nick your electric. Wiring system, cable routes. 9 times out of 10 you're going to be making this into a TT system, so there's got to be a place to put the earth electrode. And you need circuit breakers and RCDs, obviously. A site assessment is required because every site is going to be different. These things get hot, they are charging equipment, they do rectify electricity, and therefore we have got a little bit of heat problems, so there needs to be ventilation. Trip hazards, they speak for themselves with the extension leads. Obstructions, and they need to be labelling on all of your socket outlet points that should be used for electric vehicle charging only. Here's your problem with your TNCS. A TNCS system on that side there, at the transformer side, is connected to the star point, your earthing system, and at the consumer side, the neutral and the earth becomes one. Only the supply authorities can join neutral and earth together. We cannot. Ours must be separate across here, but they join it at the cutout. If they have a break in the neutral there, then all of our earthing conductor becomes the neutral conductor. We can actually get a shock between our car body and the earth below us. As I've put there, the chances of this occurring are actually 2.5 in a million, which is a lot. The problem is there has been not any vehicle charging as there is now. The last death took place in 1990 because of the lack of the neutral. But with the advent of more vehicle charging and not being installed properly, we shall wait and see the outcome. That's a picture of the rig we've got next to us, although I've turned it round. It shows that, again, we'll go through it more on the course, but you can basically get rid of one earthing system, and that's a TNS system. Cable sheath you ignore completely, because with a cable sheath system you've got to get written permission from the DNO that they will never ever ever turn it into a TNCS system. They're not going to give you that. So TNS you classify as TNCS in the future. So you've only got two earthing systems to worry about, TT, TNCS. And if it's a TNCS in the house and you're putting this outside, you're going to put an earthing rod in and TT it. Which means, as we can see from the diagram up here and from the units I've got to my left, the best thing to do, and I've gone and done that, is to put a new consumer unit in, specifically for the vehicle charging, and do that as its own earthing system. The vehicle is its own TT and the rest of the house is TNCS. The only problem you've got there is, if your car's there on the drive and that's TT, and I've got an outside light fitting just there that's metal on a TNCS and I can touch it, then we have two earthing systems, which is dangerous. That is where a risk assessment comes in, site visit comes in, because you've got to determine, can I touch that, and if I can, that light fitting must be changed to plastic. And if you've got any earthed gas pipes going around the house, they're going to need a plastic covering over them so you can't get simultaneous contact. So wiring, yes, is no problem. It's the site that you visit that might cause the problems and might increase the price of the job. The controls, again, you'll be able to see in the cabinet. I'll spin it round in a minute and you can all have a look at it and play with it. You need a suitably rated circuit breaker, preferably a Type C. These are very inductive loads, and if you've got a B-type breaker and you plug it in, it'll just keep tripping. So a C-type breaker is the norm. Also, you need an A-type RCD. Most RCDs we use, they are only susceptible to AC current. This car is a DC rectified battery. If there's a fault on the car, what we don't want is it putting fault currents back onto the system. So the RCD we employ must be able to read both AC and DC currents and trip on them both. So as you can see from here, we've got a C-type breaker, and that there is a 0.3 and it's an A-type RCD. Again, codes are in there. This one sheet here, there's about 4 or 5, maybe 6 questions on that one sheet on the City and Guilds exam. about the C-type breaker, the A-type RCD, what it's got a trip in, what the IP codes are, etc., for all this equipment. So lots of question material just on that one slide. Part of the assessment is inspection and testing. You will be expected as a part of the assessment to, I'm going to trip over this, to inspect and test the equipment that's in front of you. You'll be doing normal electrical installation tests, your R1 and R2s, insulation resistance and ZSs, RCD testing, but you need to be able to work this piece of kit as well. Simple really, it's just got a mode 3 controller in it, and you can do all your testing from that box if you like. But we are supposed to see you fill out test forms and do the testing as a part of the assessment. Although it's not in Guidance Note 3 yet as to the frequency of inspection and testing, they are anticipating 1 year. It's going to be outdoors, it's going to be used frequently, and therefore needs maintaining frequently. The DNOs have also been charged with keeping a tab on how much electric vehicle charging units are going in, so they can work out how many more power stations we need to build in the future to look after them. You must, within 1 calendar month, fill in a DNO registration to say it's in place. It's available on the DNO website. You can fill it on site, online, but it is a part of the assessment process. It's a part of the code of practice. That also goes for your checklists, your risk assessments, your Part P notification, and your electrical installation certificate. As you can see, the course is a paperwork-based course, filling out all of these pieces of paper to the right standards. Of course, they're expected.